Welcome back to the deep dive. Today, we are really cracking open a playbook for survival. I mean, in the fastest moving tech landscape we've probably ever seen.
Yeah, absolutely.
We're talking about AI strategy, but, not strategy as some static 5-year document gathering dust.
No, not at all.
Yeah,
We're talking about strategy as a constantly self-updating system.
exactly.
And the core idea here, the thesis driving this whole conversation, it comes from Zahir Ahmad Mir's fantastic book, AI Mastery for Professionals.
Right.
Mir really doesn't mince words, does he? Especially in chapter 15. He basically lays down the law. AI won't slow down for anyone. If your strategy is static, it's already obsolete.
Oof. Yeah, that really sets the tone, doesn't it? So that's our scope today. Our mission is to pull out those core principles, the architecture, the metrics, the culture, everything you need to build an AI strategy that doesn't just cope with change, but is actually designed for constant evolution. We want to help you move from just reacting to tech shifts to being genuinely future-proof.
And this knowledge, it really is custom tailored for you, the listener. Someone who needs that high-level strategic direction, sure, but also the practical ground-level blueprints to actually start building this thing tomorrow.
Right, the how-tos.
Exactly. We're diving deep into, let's call it structural agility, vendor diversification, and importantly, how you keep that learning process evergreen within your organization.
Okay, so to really understand why this flexible strategy is so critical, almost existential, we have to start with that case study Mir presents. It's a bit of a cautionary tale, isn't it? Zara, the CIO.
Ah, yes, Zara. She followed the old playbook, the one we all used to follow. Looked for stability, chose a single, highly rated AI vendor, signed a rigid 3-year contract. Seemed sensible,
Yeah, on paper it looks like certainty, right? Predictable costs, one relationship to manage.
but like we just said, in AI, certainty can actually be the enemy. The certainty she bought was really just lock-in. And her strategy started to unravel pretty drastically around the middle of year 2. And the pain points she hit well, they're pretty universal for any organization stuck with a static strategy.
Let's break those down because they really highlight why the pivot is needed. First up, tech obsolescence. She was locked into her vendor's big proprietary model,
Right.
but then boom, new models emerged. Often open source, suddenly offering maybe 20% better performance, faster inference, doing things in specialized areas her company really needed, like, I don't know, advanced legal analysis or predicting customer churn much better.
And she was just stuck watching.
Pretty much handcuffed, yeah. Watching competitors use better, often cheaper tech while she's still paying premium for last year's model.
And that lock-in, it wasn't just the contract, was it? It was the whole technical integration.
Exactly. Her entire workflow was built around that one vendor-specific API structure. So switching meant huge, expensive, really painful engineering rewrites across dozens of apps downstream.
Ouch. That's the inertia that the vendor kind of counts on. Her.
Totally. Then came pain point number 2, the regulatory shockwave. Compliance rules changed.
Always fun.
Yeah. Maybe a new law demanded specific explainability features her vendor didn't have ready, or perhaps a new data residency rule meant her data couldn't legally sit on that vendor's servers anymore.
And because her setup was monolithic, just one big block, she couldn't just flick a switch to comply.
Nope. It meant begging the vendor, waiting for their slow development cycles, dealing with deep integration changes she had zero control over. Compliance suddenly became this massive, expensive risk, potentially threatening whole business lines.
Right. And the third hit.
The unexpected cost spikes. This is where those contract details really bite you.
Ah, the fine print. Minimum commits, complex pricing tiers.
Exactly. Cost per token, cost per feature access, things that can just explode as your usage scales up, which it inevitably does if the AI is useful.
So paradoxically, if she could have switched to those newer, more efficient models, her costs might have actually dropped.
Right. But trapped, her usage went up. The vendor knew she couldn't easily leave because of, those high switching costs and proprietary data formats.
So they could raise rates.
You got it. She ended up with a system that was underperforming, non-compliant, and overpriced. The trifecta of stagnation. All because of that initial rigid strategy.
Wow. Okay, so what did Zara do? What was the fix?
Well, the fix was painful but necessary. She had to pivot. She had to build a multi-vendor modular AI layer, basically creating a layer of abstraction, like a buffer, between her applications and the actual AI engines underneath.
It's like a control panel.
Exactly. Her control panel, letting her swap out the underlying tech, the models, without needing to rewrite everything sitting on top.
And what's really key here, as Mir points out, is that the initial model choice wasn't really the failure point. It was the lack of an adaptive framework around it.
Right.
Agility, that freedom to respond, to pivot, to choose the best tool for the job. Now that's actually the highest value output of a good AI strategy. Maybe even more than the raw performance score on day one.
That's a great point. If your system can swap models in, say, 48 hours.
You've already won the strategic battle against stagnation.
Yeah. Okay, so we've established the why, the potentially staggering cost of staying static. Now let's get into the how. If we want this agility, we can't just operate in constant emergency mode, right?
No, that leads to burnout. You need structure, a predictable rhythm of review.
And this brings us to section 1, establishing the adaptive strategy loop.
Right, and this whole loop, it's anchored by something Mir calls the quarterly AI review ritual. And it's crucial that this isn't just another project management meeting.
Oh.
No, it's a deep strategic diagnostic. It's specifically designed to spot that technological drift or maybe regulatory changes before they snowball into a full-blown crisis.
Okay, so what gets reviewed? You mentioned 4 essential elements every 90 days. First is models.
Yes, performance and relevance. It's not enough just to check if the model is still, technically running.
Right, the green light is on, so we're good.
Exactly. Not good enough.
Yeah.
You have to actively benchmark it. Is there a competing open source model out there now that gives better accuracy or lower latency for like a tenth of the cost? And critically, is the underlying training data still relevant to your business today? If your model was trained heavily on 2022 data, but your market totally shifted in 2024, well, that model might be subtly misleading you based on outdated assumptions.
Okay, relevance is just as key as raw accuracy. Got it. What's the second element?
Costs. This one can be really dynamic and, frankly, tricky, especially when you're juggling multiple vendors.
I can imagine.
Yeah, so cost monitoring has to be granular. You're not just glancing at the quarterly invoice total. You need to be auditing inference costs, looking for those weird, unexpected spikes in cost per token.
So finding out if, like, one team is suddenly hammering the most expensive general model for tasks a cheaper, specialized one could handle.
Precisely. Or maybe usage patterns have accidentally bumped you into a way higher pricing tier you didn't anticipate. The goal here is constant optimization through, well, competitive leverage if vendor A jacks up their prices.
The quarterly review should trigger a look at shifting some workload to vendor B, right?
Exactly. Keeps everyone honest. Okay, third element, compliance. This is like the legal immune system for your strategy.
Because regulations are moving almost as fast as the tech now.
They really are, faster than most legacy internal processes can handle. So you need that dedicated legal and compliance audit every single quarter.
Proactively checking against new government rules, industry standards, maybe even those geo-specific things like data residency.
Absolutely. The review has to ask, are we still operating within the bounds of that new automated decision-making law? Do we need to update our internal logging to meet new transparency demands? Doing this every 90 days prevents those legal bombshells from catching the tech teams completely off guard and forcing a chaotic scramble.
Makes sense. And the final element.
Overall performance. This kind of synthesizes everything. Are we actually achieving the ultimate business goal we set out for this AI?
So if the AI was meant to cut call center handle time by 30%,
is it actually hitting 30%? Or has it maybe drifted down to 15% because of subtle model issues or changes in how users are interacting with it? You got to keep your eye on the prize.
Okay, so models, cost, compliance, overall performance, reviewed every quarter. Why quarterly? Why not monthly or every 6 months?
Yeah, Mir is quite specific about that cadence. It's about balancing responsiveness with sustainability. If you wait 6 months in AI time, that's an eternity.
Yeah.
You risk falling way behind competitors or getting hit by a regulation you didn't see coming.
Okay.
But if you try to do this deep strategic review every month, you just burn everyone out. The analysis becomes too shallow to really drive meaningful architectural changes. Quarterly seems to be that sweet spot, enough time for trends to emerge, but frequent enough to react effectively.
Right, strategic depth without the burnout. Okay, that covers the rhythm. Now, what about the specific metrics? If agility and resilience are the goals, what key performance indicators, what KPIs should we really be tracking beyond just, is the system up?
Good question. The KPIs generally fall into 3 main buckets, giving you that holistic view. First, pretty obviously, is quality.
So accuracy and latency.
Primarily, yes.
Yeah.
Accuracy, how often is the model right? And latency, how fast does it give you a usable answer?
And latency can be sneaky important, can't it?
Oh, absolutely. For some internal back office task, maybe a few seconds delay is fine. But if that model is powering your customer service chatbot in real time,
Yeah.
and the response time creeps up from half a second to 3 seconds, the whole user experience just falls apart. People bail. So, high latency can kill the perceived quality, even if the answer itself is technically correct. You're measuring the responsiveness of the intelligence.
Okay. Quality. What's the second bucket?
Second is safety. And this one requires some sophisticated testing. How do you actually measure safety in these dynamic systems?
Yeah. How do you put a number on that?
Well, the source material is pretty clear. Safety is quantified mainly through the results of red team exercises.
Okay. Explain red teaming in this context.
It means you have dedicated teams, internal or external, whose job it is to continuously, intentionally try to break your deployed models. They run adversarial attacks.
Trying to make it malfunction.
Exactly. They might use clever jailbreaking prompts to try and trick a system handling internal financial data into leaking sensitive customer info, or maybe try to force it to generate biased loan recommendations.
Okay.
The model's safety score is based on how well it resists these attacks, how quickly its built-in guardrails stop the misuse, and importantly, whether the system logs the attempt for later audit. A high score here gives you confidence in its robustness against misuse or, going off the rails.
Got it. Quality, safety. And the third KPI must be the business case.
Yep, the anchor. ROI, return on investment. If you can't clearly map the AI system back to concrete business value like measurable revenue gains, real cost reductions, or specific risk mitigation, then frankly, the fanciest adaptive architecture in the world is just a science project.
A very expensive science project.
Exactly. ROI is the constant justification for every piece of this tech stack. It keeps things grounded in business reality.
So this structural rigor, the quarterly review, the 3 KPI buckets that needs to be supported by how you actually implement change, right? Mir has a mandate here too, doesn't he?
He does. Ship small improvements monthly. And actively, deliberately avoid those massive, disruptive, organization-wide Big Bang migrations.
Why is that cadence so important, small and monthly?
It's about normalizing change, making it routine. Small monthly updates, maybe tweaking a prompt template, swapping a model for one specific low-risk task, adjusting the orchestration logic slightly. They're much easier to test thoroughly.
Easier to roll back if something goes wrong too, I guess.
Precisely, and crucially prevents the buildup of technical debt. That situation where you haven't touched anything for 2 years, and now you have to do a massive, risky, year-long system overhaul.
The Big Bang.
Right. Those Big Bang migrations are basically the ultimate symptom of a static, unhealthy strategy. Continuous small iterations are the sign of an adaptive, resilient one.
Okay, we've got the rhythm of adaptation nailed down with that quarterly review. Now let's shift to the engineering. How do you actually build a tech stack that can handle that constant change? That's section 2. Architectural pillars of flexibility. And it seems to kick off with vendor diversification.
Yeah, this flows directly from Zara's cautionary tale, doesn't it? The core architectural aim is to use the best tools out there, the specialized ones, without getting locked into any single provider.
So you're mixing the big general foundation models, the LLMs, with maybe more niche, fine-tuned models for specific jobs.
Exactly. And the mantra underlying all of this is crystal clear. Do not depend on one API, period.
Okay, but doesn't running multiple vendors just create chaos? How do you manage all that complexity?
You manage it with smart engineering, control, and that leads straight to the absolute necessity of an abstraction layer.
Okay, what is that practically?
Think of it as a unified gateway, maybe an AI switchboard, or perhaps a universal software development kit, an SDK. It sits between your internal applications and that whole collection of different AI models you're using.
So if I'm a developer building an app, I just talk to this abstraction layer. I send it a request like analyze this customer ticket.
Yep.
And then the abstraction layer itself figures out whether to send that request to, say, OpenAI or Anthropic, or maybe an internal open source model you're running based on rules you set.
Precisely. It acts as a translator between formats, a smart router based on cost or latency or the type of task.
Right.
And it's a standardized place to log everything.
And the logic inside that layer can be dynamic.
It has to be. For instance, if that customer ticket is flagged as, say, highly sensitive or involves a complaint, the abstraction layer might automatically route it to a specialized model known for really good sentiment analysis, even if that model costs a bit more.
But if it's just a routine, where's my order type question?
It routes it to the cheapest, fastest, good enough general model. You optimize automatically based on context.
Okay, so that ability to swap models quickly, without forcing all your downstream apps to rewrite their code every time, that's the heart of agility. But I gotta ask, what's the downside? Doesn't building and maintaining this custom abstraction layer add complexity? Doesn't it slow you down initially compared to just using vendor X's fully managed all-in-one service?
That is the essential strategic trade-off, yes.
Yeah.
There absolutely is an initial overhead. It costs time and engineering effort to build that layer correctly.
Right.
However, that cost is an investment. It's an investment in future resilience and freedom. Because when vendor A suddenly hikes their prices by 50%, or maybe their API goes down for a critical hour during peak season,
The organization that just went all in on that single managed service is stuck,
Ah,
paralyzed.
totally paralyzed. Meanwhile, the organization with the modular architecture just updates the routing logic in their abstraction layer,
Mm-hmm.
maybe points the traffic to vendor B or their backup model and keeps operating, sometimes within minutes.
So that initial complexity cost pays for itself potentially many times over by mitigating future risks and cost shocks.
Exponentially. It's insurance against vendor lock-in and market volatility.
Okay, that makes sense for the code and the APIs, but you
Yeah.
mentioned earlier, none of this flexibility works if your actual data, your company's knowledge, is stuck somewhere, right? We need to talk about data portability as a foundation.
Oh, absolutely critical. Data lock-in is the ultimate anchor dragging down any attempt at agility. If your data is trapped in a proprietary format, everything else we're talking about is just, well, window dressing.
So Mir emphasizes standardizing data, schemas, exports.
Yes, schemas, how you export it. And this is super critical for modern AI, your vector formats.
Okay, why the heavy focus on vector formats? Why are vendor-specific vector embeddings the ultimate lock-in trap?
Right, let's unpack that because it's a key technical point. Vector databases are how these AI systems, especially those using retrieval augmented generation or RA.
Which is most sophisticated enterprise AI now.
Exactly. That's how they quickly find relevant information within your vast pool of company documents, your knowledge base. When you upload all your manuals, reports, past customer interactions, whatever, the system converts that text into numerical representations, vectors, or embeddings.
And the AI uses math on those vectors to find related concepts, even if the keywords don't match exactly.
Precisely. Now, here's the catch. Many vendors use their own proprietary models to create these embeddings, or they use indexing algorithms that are highly optimized for their specific vector database structure.
Uh-huh.
So if you've spent months and significant compute costs generating millions, maybe billions of these vector embeddings and indexing them in vendor X's special format, getting that data into a format that vendor Y's system can understand is incredibly difficult and expensive.
You might have to reprocess everything from scratch.
Often, yes. Rerunning the entire embedding generation process.
Yeah.
If you've got terabytes of source data, that's a crippling cost and time sink. It effectively locks your knowledge base to that vendor.
So the solution is?
Standardize from the start. Ensure your vector embeddings are generated using open models where possible and stored or exported in open common formats. That way, your core knowledge base can move with you if you need to switch model providers or database backends. You decouple the knowledge from the engine.
Okay, so if we tie all this engineering stuff together, the abstraction, the data portability, it sounds like the goal is creating really clean lines of separation between components. The source material lays out a 4-layer modular architecture, right?
Yes, and this separation is the blueprint for agility. You create independence between 4 distinct layers, so a change in one doesn't ripple through and break the others.
Layer 1, as we just hammered home, is data. Your input, your knowledge base got to be decoupled and portable.
Check. Layer 2 is orchestration. This is the brains of the operation, deciding the flow. It manages the sequence of steps, the routing logic we talked about with the abstraction layer. It's independent of the actual AI model doing the work.
Can you give an example of orchestration?
Sure. Let's say an employee asks the internal HR but a question about benefits. The orchestration layer might decide. Step 1, check the question against a compliance model, which is in layer 3, to ensure it's not asking for restricted info. Step 2, send the vetted question to a large general model, layer 3, to generate an answer. Step 3, maybe send that draft answer to a smaller, cheaper model, also layer 3, just to summarize it concisely before step 4, passing the final result up to the application layer.
Got it. So layer 3 is the model's layer itself. This is where all those different AI engines live, the proprietary ones, the open source ones, all sitting behind that abstraction layer, ready to be swapped.
Correct. And finally, layer 4, right at the top, is the applications, apps. These are the actual end-user services, the chatbot interface, the report generation tool, whatever the user sees.
And the beauty is that app layer only ever talks to the orchestration layer.
That's the key. The developers building that front-end app, they never need to know or care if you just swapped out OpenAI for Claude or replaced a niche vendor with an internal fine-tuned model down in layer 3. They just get the consistent, expected output from the orchestration flow. It simplifies life immensely for the app teams.
Okay, the architecture is designed for change. But how do we prove a new model we want to swap in is actually better or safer before we unleash it on the whole company? We need a standard way to evaluate them, right?
Absolutely. This demands what Mir calls a central evaluation harness. It's basically a requirement for a standardized, consistent set of tests that you run against every model you're considering. The same tests across all models.
So if you're testing models for, say, summarizing legal contracts, you use the exact same 100 contracts and the exact same grading rubric, whether it's vendor A's specialized legal model or a big open source model you tweaked yourself.
Exactly. Apples to apples comparison. Objective performance data.
Okay, running the same 100 questions makes sense for consistency, but isn't there a risk that your evaluation harness gets stale? Like, you end up testing for yesterday's problems and miss how well a model handles new challenges. How does the harness itself stay adaptive?
That's a really important point. Yes, you need that stable baseline set of golden questions for consistent comparison and compliance checks. But the harness itself must be part of that quarterly review process we discussed earlier.
Ah, okay.
The red team exercises, the safety testing, they should constantly be feeding new, difficult adversarial test cases back into the evaluation harness. So while the core evaluation methodology stays standardized for comparison, the content, the specific tests within the harness needs continuous refreshing to push the boundaries and test for emerging risks or new competitive performance levels.
Okay, so the harness evolves too. Now, let's say a new model passes the harness test with flying colors. How do we introduce it safely into the live system without risking everything if we miss something?
Right, you don't just flip the switch for everyone overnight. You leverage modern software engineering practices, specifically the tactical use of feature flags.
Explain feature flags in this context.
Feature flags are like software toggles. Instead of deploying the new model to 100% of your users immediately, you use a feature flag to route, say, just 1% of your live production, traffic, real customer requests through the new Model X.
While the other 99% keeps using the old stable Model Y.
Exactly. This lets you run a live A/B test. You can directly compare the performance, the latency, the costs, and crucially, the safety outcomes of the new model versus the old one, using real-world traffic, but with minimal blast radius if something goes wrong.
So you catch those weird edge case failures or maybe subtle increases in latency or cost before you commit to a full rollout. Minimizes the risk significantly.
Precisely. It's controlled exposure. You gather real-world data, build confidence, and only then do you gradually ramp up the traffic to the new model, maybe going from 1% to 10% to 50% to 100% over days or weeks, watching the metrics all the way. Safe implementation is key.
All right, we've designed the resilient tech architecture. We know how to test and deploy changes safely. But, as always, the best infrastructure is kind of useless if the people, the human system, isn't ready to actually use it effectively, right?
Absolutely. Which brings us neatly to Section 3, cultivating an evergreen learning culture. Your organization's knowledge base has to evolve just as fast as the AI technology itself.
Adaptation beats prediction, as you said, but only if your people are actually equipped to adapt.
Exactly. And this can't be passive. It requires systematic, even mandated knowledge building. You can't just hope people will pick things up in their spare time or through osmosis.
And the source material is very specific here, isn't it? It details a non-negotiable mandate, a 2-hour weekly learning block per team.
Yes, dedicated time, protected time, solely for developing AI skills, exploring new tools that have emerged, reading new research papers, or doing hands-on experimentation relevant to that team's specific work.
2 hours a week per team? That sounds like a lot when everyone's already busy. How
Yeah.
critical is protecting that time?
It's fundamental.
Mm-hmm.
You know how it is in high-pressure environments? The first thing that gets squeezed off the calendar when deadlines loom is non-urgent stuff like training or learning.
Yeah, L&D is often the first budget cut.
Exactly. But if you don't religiously protect those 2 hours, your organization will fall behind the curve. Your fancy modular architecture will become unusable because nobody knows how to evaluate that promising new open source model, or how to integrate it, or even what prompts work best with it now.
So you have to treat learning not as a perk, but as a core operational investment, like server maintenance or patching.
Precisely. It's essential upkeep for your human capital in the age of AI.
Okay, that covers individual and team growth. But if you've got, say, dozens of teams all spending 2 hours a week experimenting and learning, how do you stop that knowledge from getting lost? How do you capture all those decentralized lessons, the wins, but also the mistakes?
Great question. That knowledge can't just stay siloed in individual team Slack channels or wikis. That's the purpose of the internal AI Guild.
An AI guild. What is that exactly? Sounds a bit formal.
It doesn't have to be overly bureaucratic. Think of it as a dedicated regular forum. Maybe it's a monthly meeting, the dedicated online space, whatever works specifically for institutionalizing that knowledge sharing. It's the structured way to have those valuable water cooler conversations about what's actually working with AI.
And what kind of knowledge gets shared there? Are we talking high-level strategy or practical tips?
Mostly practical, tactical, hands-on stuff. That's the most valuable currency in the guild. Things like, hey, we discovered this specific prompt structure gets way better results for generating marketing copy, or sharing effective techniques for fine-tuning models.
Or maybe project wins, like our team used this new ROG technique and cut research time for analysts by 40%. Here's how we did it.
Exactly, demonstrating real value. And just as importantly, sharing the lessons learned from failures. This is crucial. If the engineering champion in one team discovers that, say, a particular way of deploying a model led to unexpected output drift after a week.
Sharing that failure openly saves 20 other teams from making the same costly mistake.
Precisely. Fail fast, learn faster, and share the learning instantly. That's the guild's function.
Okay, but who drives this? Does the expertise still end up concentrated in a small central AI team, like a center of excellence? Because that sounds like it could become a bottleneck again.
It absolutely can,
Yeah.
and that defeats the purpose of agility. So the final cultural piece here is distributed ownership,
Me neither.
meaning you need mechanisms to push AI expertise and responsibility out into the business units. The source specifically mentions the concept of having a rotating AI champion in each department.
An AI champion. So someone in marketing, someone in sales, HR, finance, etc., who is the go-to person for AI in their area.
Exactly. And importantly, this person isn't necessarily a PhD data scientist. They're more likely a power user from within that department, someone who understands the business context deeply and is enthusiastic about applying AI to it. They act as the expert liaison.
Okay, but if they're not deep technical experts, how do you make sure this champion role isn't just, a title? What actual power or resources do they need to have to drive change effectively in their department?
That's the critical question. They need two specific things, according to Mir. First, they need the technical authorization to actually run experiments within that safe feature flag and evaluation harness environment we talked about, specifically for their department's use cases.
So they don't need permission to deploy to everyone, but they need the keys to the sandbox to test things out.
Exactly. They need to be able to try things. Second, they need a degree of budgetary autonomy. Maybe a small protected budget allocation they can use to trial a promising new low-cost API or experiment with an open source model relevant to their field without needing to go through 3 layers of centralized procurement approval for a $50 experiment.
Okay, so permission to test and a small budget to try new tools. That empowers them to take the cool ideas they hear about in the AI Guild.
Bring them back to their own team's 2-hour learning block and actually start trying to operationalize that innovation quickly, right where the business need is. It closes the loop between central learning and distributed action.
Okay, we've built the flexible architecture, we've cultivated the adaptive learning culture. Now the final piece of the puzzle, actually shielding this dynamic system.
Yeah.
Section 4 is all about risk and compliance readiness.
Right, because the more adaptive and modular your system becomes, the more you're swapping components in and out.
The greater the need for really clear, robust guardrails becomes. Flexibility without control is just chaos, right?
Couldn't have said it better. Because you're potentially introducing new models, new code, new vulnerabilities constantly, you need proactive risk mitigation tools baked right into the operational flow.
The source mentions one key tool for sensitive tasks, standardizing the input using pre-approved prompts. What does that mean in practice?
Think of it as a way to control the interaction, especially for tasks where accuracy and safety are paramount. It helps combat things like prompt injection attacks or just the model drifting into weird territory.
So instead of letting a customer service agent type absolutely anything into the AI assist tool,
The system might only allow them to select from a drop-down list of vetted, pre-approved prompt templates. Maybe summarize this customer's issue, or draft a standard follow-up email, or explain policy X.
And these templates have been thoroughly tested, red-teamed, checked for bias, proven to generate safe and compliant outputs.
Exactly. It limits the degrees of freedom for the input, which in turn limits the potential for the model to generate unexpected, risky, or non-compliant output. It's a constraint, but a necessary one for high-stakes interactions.
Okay, pre-approved prompts for some tasks. But what about the really critical decision that the AI might recommend? Is there still a need for a human safety net?
Absolutely. For the most critical stuff, the final backstop is still human in the loop, HIL. This means mandating human review and explicit approval for all high-impact decisions that the AI might propose or make.
And the key is defining high impact clearly, I suppose.
Yes, you have to set clear thresholds. HIL isn't needed for every single AI output. That would grind everything to a halt. It's reserved for decisions carrying significant weight, maybe regulatory, financial, or reputational consequences.
So rule of thumb might be any decision over a certain dollar amount, say $10,000, or anything involving sensitive customer data or legal status changes.
Exactly. Things like large financial transactions, complex medical diagnoses proposed by an AI, critical infrastructure adjustments, final loan approvals, these should probably require a human to review the AI's recommendation and give the final okay. The AI provides the analysis, the recommendation, maybe drafts the action, but the human retains the veto and holds the ultimate accountability.
Okay, so we have input controls and output reviews. But what happens when something inevitably goes wrong? The adaptive system hits a snag, a model misbehaves, a gateway fails. Or worse, you discover a compliance breach. Speed is critical then, right?
Paramount. Speed and transparency. This is where having an essential incident playbook ready beforehand is non-negotiable.
And this playbook needs to be designed specifically for this kind of modular, fast-changing environment.
Yes, it focuses on immediate containment and recovery, built around 3 core pillars. Pillar number 1 is immediate rollback. Meaning your architecture, especially that abstraction layer, has to be built so that if Model X suddenly starts failing safety checks or spitting out garbage, you can instantly, maybe even automatically, flip a switch and revert all relevant traffic back to the last known good stable Model Y.
Without needing hours of manual reconfiguration and a panic.
Exactly. Minimize the exposure window, stop the bleeding instantly. That's the power of the swappable architecture, but you need the process defined to use it.
Okay, rollback. Pillar 2.
Audit. You need comprehensive tracking and logging at every stage of the process, not just what the end application saw.
So the abstraction layer needs to log which specific model got the request, what transformations the orchestration layer applied, what the raw output from the model was before it got processed further.
All of it. Without that clear, standardized logging across your potentially multi-vendor backend, you have absolutely no way to reconstruct what actually happened when something goes wrong. You can't satisfy our regulatory auditors. You can't do a proper root cause analysis. Your due diligence capability depends entirely on that audit trail.
Makes sense. Rollback, audit. What's the third pillar?
The third pillar is one that often gets overlooked when engineers focus just on the tech. User communications.
Telling people what happened.
Yes. Transparency builds trust, or rebuilds it after an incident. Your playbook must include predefined communication templates and clear escalation paths for informing end users, internal stakeholders, maybe even regulators, quickly and honestly about what went wrong.
So if the AI system is temporarily down, or if it made an error that might have affected some users, getting ahead of it with clear communication is better than letting rumors fly.
Much better. It limits reputational damage, manages expectations, and fulfills ethical obligations, especially if sensitive data or critical decisions were involved. Don't hide it.
Okay, this all sounds great in theory. Let's make it concrete. The source material provides a really good professional example of how these architectural pillars actually paid off, right? The regional bank.
Yes, it's the perfect illustration of the whole adaptive strategy in action. Mir describes this regional bank that had done the hard work. They'd built the model gateway, they'd standardized their data formats, particularly vectors. They had the governance controls like the review process in place. They built the modular system.
And then reality hit. The real-world test came along.
Yep. Legal mandates changed practically overnight. Maybe a new financial regulator suddenly demanded that all loan decision models had to incorporate some specific, newly defined fairness metric that their main incumbent proprietary vendor hadn't implemented yet and wouldn't have for months.
So under the old static model, they'd be stuck, non-compliant, waiting.
Exactly. But because they had the modular architecture, they weren't stuck. They didn't have to wait for vendor A's slow roadmap.
Oh, did they do?
They used their abstraction layer. They quickly sourced a different model. Maybe it was a smaller specialized fintech vendor, maybe even an open source model they could fine-tune quickly that already incorporated the required fairness metric.
Plugged it into their gateway.
Ran it through their central evaluation harness to rigorously verify its performance and compliance against the new rule.
Yeah.
Deployed it carefully using feature flags, starting small.
And the result was the key metric here.
The result was the metric that matters most to the business: zero downtime. Customers were completely unaffected by this major underlying regulatory shift. The bank used its architecture to hot swap to a fully compliant model in just 48 hours.
Wow. 48 hours to respond to a major regulatory change without disruption.
It perfectly proves the value proposition. Adaptation beats prediction. They didn't need to guess which regulation was coming. They just needed the built-in ability, the architectural and cultural readiness to respond instantly when it arrived.
That's powerful. It turned a potential compliance disaster into almost a non-event, maybe even a competitive advantage if their peers were slower.
Exactly. That's future-proofing in action.
Okay, this has been a really deep, structured dive. We've pulled out the absolute core principles from AI Mastery for Professionals on building that flexible, adaptive AI strategy. Let's try and summarize the main takeaways. What are the big three messages?
I think the first overarching one is adaptation beats prediction. Stop tearing your hair out trying to guess the winning AI model 5 years from now. It's futile. Instead, focus your energy on engineering a system that can absorb and leverage the winner, whoever it turns out to be, quickly and without needing a painful multi-year rebuild.
Right. Build for change. Don't try to predict the unchanging. Okay, takeaway number 2.
Diversify vendors, but standardize evaluation. Yes, you absolutely should leverage the best specialized tools out there from multiple providers. Don't put all your eggs in one basket. But you manage the inherent complexity that comes with diversification by building those abstraction layers, ensuring your data is universally portable, and critically, using that central evaluation harness to maintain objective apples-to-apples comparisons between all tools. Control the chaos.
Diversify the options, centralize the control and measurement. Got it.
And the third key takeaway: make learning a system, not just a slogan. It's not enough to say you value learning. You have to embed it operationally. Mandate and protect that 2-hour weekly learning block for teams. Institutionalize the sharing of practical knowledge through something like the AI Guild, and distribute the ownership and expertise using rotating AI champions in each department. Your organization's collective knowledge needs to be just as adaptable and evergreen as your tech stack.
Adaptation beats prediction. Diversify vendors. Standardize evaluation. Make learning a system. Fantastic. Okay, now for our final thought for you, the listener. If building this kind of fully adaptive strategy sounds, well, huge, like a massive multi-year transformation, and let's be honest, it can be, the real challenge is often just getting started and protecting that start.
Yeah, that bank example is great because it proves the tech is solvable. You can build a modular architecture. But the real bottleneck in achieving that 48-hour swap wasn't just the code. It was probably the organizational culture. Did they have the processes, the trust, the lack of blame required to move that fast, to potentially fail safely during testing, and to learn from it instantly? So maybe the question for you to reflect on this week is less about the tech and more about the culture. What rule, what bureaucratic hurdle, what fear of failure, or maybe just internal skepticism is currently stopping your team from even trying something small, like actually implementing that 2-hour learning block, or running a tiny safe experiment using feature flags to test a slightly cheaper alternative model in your environment?
Because future-proofing isn't really a destination you arrive at.
No, not at all. It's a habit. It's a muscle you build. And you start building it by making one small change today, by challenging one piece of the status quo. That's how the shift from reacting to evolving actually begins.